A train is traveling on a straight track at a constant speed of 78 kilometers per hour and doesn't make any stops. The train passes by station B, and then 1 minute later it passes by station C. How far apart are stations B and C in meters? Okay, let's read that again and highlight the important information. We have a train traveling on a straight track at a constant speed of 78 kilometers per hour, so there's no acceleration. Next, the problem says the train passes by station B, and then 1 minute later it passes by station C. So station B and C are basically points on the path of the train, and they're 1 minute apart. The question is asking us how far apart are stations B and C, specifically in the unit of meters. Let's draw a picture to represent the scenario. We have a train that's moving at a constant speed, so we'll draw a vector to represent the velocity of the train. There's 2 points for stations B and C, and they're some distance apart, which we'll call a displacement delta x. Also, the train takes some period of time to move between the points, which would be delta t. Let's just use variables in our picture and write down on the left that the velocity is 78 kilometers per hour and the period of time is 1 minute. Remember, speed is the magnitude of the velocity, and since we just have a constant speed in a straight line, the velocity would be 78 kilometers per hour, or you can just refer to v as the speed. Next, let's write down that we're trying to find the displacement, or the distance between the two stations, which is delta x, and that needs to be in meters. So what equations can we use to solve this? The train is moving at a certain velocity, which we know, and it travels for a certain amount of time, which we also know, and we want to find the displacement of the train. So we can use the same velocity equation as last time. Since we're saying the displacement is in the x direction, you could write this as Vx, but we'll just use V. Now let's work through the problem. First, we need to realize that the answer needs to be in meters, but we're given a speed in kilometers per hour and a time in minutes. So we need to convert those units before we start. To do that, we use a method called dimensional analysis, which is writing out all of the unit relationships as fractions that we multiply together. For the velocity, we start with 78 kilometers per hour, but written out as a fraction. To convert from kilometers to meters, we multiply by the relationship of 1,000 meters per 1 kilometer. Now, kilometers is on the top and the bottom, so the unit of kilometers cancels out. Then we'd have meters per hour. So to convert from hours to seconds, we multiply by 1 hour per 60 minutes and 1 minute per 60 seconds. Then hours and minutes cancel out. When we multiply these fractions, we get 21.67 meters per second for the velocity. Let's write that in the box on the left. And for the period of time, delta t, we know 1 minute is 60 seconds. Now everything is in SI units. Alright, so let's use the velocity equation to solve this. First, we can rearrange the equation by multiplying both sides by delta t and flipping the left and right sides, so delta x is on the left. Next, we plug in 21.67 meters per second for the velocity and 60 seconds for delta t. That gives us 1,300 meters for the displacement delta x. Now let's check our answer. We only dealt with positive numbers and positive directions, so the answer should be positive. The value seems reasonable, but we could plug it back into the equation we used if we want to double check. And we have the right units. We were looking for an answer in meters, so this looks right.